Hey guys, I'm going to walk you through how to do number 7 here on the group assessment. So we're given consider the problem of y double prime minus 2 plus 2 over t y prime plus 1 2 over t y equals e to t, and then we have t is greater than 0 right here. And then the first part, it also gives us that suppose y1 of t equals e to t, solution of the corresponding equation above, and it's homogeneous. And then the general solution, we're supposed to find that yc of t in the part A, and then in part B, we're supposed to find y of t of the original. But we'll get onto it a little later. So first step I did here was we're gonna do y equals v times e to t, and then v is a function of t. I just want to substitute it in. This way we're gonna, next step here is gonna take the derivative of this following function. After evaluating all of that, we got product rule, and then within that, I simplified it further. We got d of y equal over dt equals e to t dv over dt plus v e t. So now that we've found that value, we're going to plug it back in the original equation, and we substitute it for each single step. In this case, we're going to sub back into y double prime minus 2 plus 2 over t y prime plus 1 plus 2t y equals e to t, and then substituting it in, you can see what I got here is 2et dvt plus et d squared v over dt squared plus v et minus 2 plus 2 over t, and then in brackets e to t dv dt plus v et plus 1 plus 2 over t v et equals 0. So the next part is, here we go. Next part is simplify that even further. I got rid of all the e to t's, divided to the other side. And we're also, remember that we're given t is greater than 0 and that e to t is also greater than 0. But it's from just what we figured out. We just got this big equation, and I'm going to show you what to do for the next part here. So simplifying that big equation on the other page, we're going to get d squared v dt minus 2t 2 over t dv dt equal to 0. Now we're going to use the value of p here as well, and then integrate, and then use that, differentiate it. So we have dp over dt minus 2 over tp equal to 0. Set each value to the other side, and we get dp over dt is equal to 2 over tp. And then I got the like functions together here, p on each side, and then t on this side. And then I want to integrate using log, because we had e to t earlier. Log p is equal to 2 log t plus log c, and then canceling out, we got c plus 2 equals p. And then we want to take the derivative and integrate eventually, so I put dv over dt is equal to ct squared, comma p equals dv over dt. Integrate both sides, we eventually get ct cubed over 3 plus c1, and then we're going to plug that back into here. Y is equal to e to tv, which is equal to e to t brackets e to t cubed over 3 plus c1, and then this is the final answer of c over 3 e t t cubed plus c1, and then e to t. So that's 7a. Now 7b asks us a little different. So it wants us to find a general solution of y of t of the original homogeneous equation. Same steps as earlier before, a little similar. We got y is equal to etv, and then we plug into this whole equation again. And then after plugging it in, we're going to simplify down to this equation. D squared v over dt squared minus 2 over t dv dt is equal to 1. And then we have dv over dt is equal to p. Now we have dp over dt minus 2 over t, p is equal to 1. Now we're going to integrate that whole thing that we just found right here and plug it into the e. And we're going to get integrate on top, and we get negative 2 log t equal to e 2 log 1 over t. And now we're going to use the value of 1 over t that we just found here, t squared, sorry, P times 1 over t squared, integrate that to find C2 now. And then we're going to add that to C2. We got 1 over t plus C2. P is equal to negative t plus C2 times t squared. Integral of dv over dt is equal to negative integral of t dt plus integral of c2 t squared dt plus c3. We want to find c3 now, so v is equal to negative t squared over 2 plus c2 t3 over 3 plus c3. Y is equal to negative e to t t squared over 2 plus c2 t cubed over 3 e to t plus c e to t. Okay, so sorry for the background noise. It's a little noisy in the house. Let's see here. Just give me a second.
Hey, I'm taking a class right now.
Sorry about that. So this is our final answer for 7b, the final solution. We have a couple constants here that we did not solve for, but that's okay. It just wants us to find the general solution and not the given as well. So moving on to number 8. Scroll down here. A spring mass dash pot system consists of 10 kilogram mass attached to a spring with a constant of K equals 100 N over M, and then the damping constant is N second over M, and at time T equals 0, system is set in motion, pulling the mass down 0.5 meters from equilibrium while giving it simultaneously an initial downward velocity of 1 meters per second. So, first thing is asked us to state the initial value problem to be solved for y of t, displacement from equilibrium in meters measured towards a positive direction. Alright, so first step here, I've written down the givens. M equals 10 kilograms, K is equal to 100 N over M. Damping constant is N second over M. At T equals 0, mass is pulled down 0.5, and we also give them velocity, downward velocity of 1 meter per second. So we're going to use a differential equation of the form we've seen before. We have my double prime plus y prime and the damping constant plus ky is equal to 0. So plugging in our values we have up here, we have 10y double prime plus 7y prime plus 100y is equal to 0. T equals to 0, and then y0 is equal to 0.5, and then y prime of 0 is equal to 1. So we just plug everything in, and we got the simple equation of 10y double prime plus 7y prime plus 100y is equal to 0, and then comma y of 0 is equal to 0.5, and then y prime of 0 is equal to 1. So the next part here is going to be a little more complex. It wants us to solve the initial value problem and find the limit of, as t goes to infinity, y of t. First step here, I broke it down using quadratic formula, since it has non-real roots and we have I here. So I replace the values here with r, set it equal to 0, solve for r, reduced it down to here. And here we have 3 times square root of 439 divided by 20. And that gives us approximately 3.1428, close to pi, but we're just going to use the value of 3.14 for this example. And we're going to use this formula here. Y of t is equal to E of t, C1 cosine B of t plus C2 sine of B of t. Now we're going to plug everything in. And here we know that negative 7 t over 20, we're going to plug it into the exponent here. And then we have C1 cosine of 3.14t plus C2 sine 3.14t as well. And now we're going to want to find C1 and C2. So using the additional condition it gave us, y of 0 is equal to 0.5 meters, or pull down 0.5 meters. We set 0.5 equal to this whole thing. Plugging in values, cancel out. We got 0.5 is equal to 1. C1 times 1, because cosine of 0 is 1, plus C2 times 0. And now we find that 0.5 is equal to C1. So next step, we've got to find C2 using derivative, but we need to find derivative of y first. So we're going to set the whole thing, y of t is equal to dt. Take derivative of this whole thing, and then remember, use product rule for this part. E negative 7t over 20 d of t, C1 cosine 3.14 t plus C2 sine 3.4 t plus, take the derivative of this part, e to the negative 7t over 20, C1 cosine 3.14 plus C2 cosine of 3.14 t is equal to this whole thing right here. I'm getting a little redundant, so I'll just let you take a look here. Exponent, we're taking derivative here, so this exponent goes down towards the front, and then this comes negative because it's went from cosine to sine, and it's negative in front there. As you can see, this stays positive because it's sine and cosine. Now after that, we can plug in the initial condition of y prime of 0 is equal to 1. That's what they gave us. So set 1 is equal to this whole thing we just found, and plug the zeros in. Find what cancels, reduce it down to 1 times negative 3.14 c times 0 plus 3.14 c2 times 1 minus 1 c1 plus c2 times 0. So here now, after I'll do all that, we should get 3.14 c2 minus c1. Recall earlier that we got c1 is equal to 0.5. As you can see right here, 1 is equal to 3.14 c2 minus 0.5. Solving for c2 equals 0.478. Now we're going to rewrite the whole equation, plugging in c1, c2. Y of t is equal to negative 7t over 20, brackets, 0.5 cosine 3.14 t plus 0.48 sine 3.14 t, brackets. And that's our initial value problem. Next step is to find the limit as t go to infinity of y of t. This step, you need to know that the constants of c1 and c2 are bounded by positive and negative value, so just -1 and +1. As you can see here, we have the negative on this side, y of t in the middle, and then positive on this side. Take the limit of each side as t goes to infinity. We get 0 over here, and then